Packet lesson 3-1, day 2. Go to page 83. Here it is. Fundamental identities. But I think you should actually call it solving equations that involve trig. That'd be a better title. All right. First of all, let's analyze the instructions. Find all solutions. Look at that. That's a huge clue. That means there's probably more than one, a lot, to the equation in the interval. Now, I haven't said this yet, but that little bracket means that it can include 0 as an answer. This parentheses means don't include 360. If you think about it, 360 is the same thing as 0. So they're saying take that as an answer, but don't repeat it by putting 360. But anything less than 360 can be considered an answer as well. Well, we need to just start by dividing by -2 and get this alone. And then I'd get the square root of 2 all over 2. Where do I put the negative? Well, I don't leave it in the bottom because my hypotenuse is never, ever, ever negative. Remember, this is opposite. Sorry, I almost put adjacent. Opposite over hypotenuse. So I need to find out all the degree measures where if I spin my spinner, I'm going to get a negative square root of 2 over 2. Well, everything's positive here, so I know it can't be here. I know sine would be positive here because if I have a reference angle, there's my opposite, there's my hypotenuse, so it can't be in this quadrant. So the only place that can happen is the quadrant 3 and 4. Remember, the square root of 2 is screaming out that there's a very high probability that there's going to be a 45, 45, 90. So we're going to put all our chips in the middle and say, let's gamble and go for it. So we're going to put our hypotenuse as a 2, our opposite as negative square root of 2, and let's make sure that this is following the x square root of 2 rule. If I multiply this, just this part, not the negative, by the square root of 2, I would get 2. So yeah, it's a weird one, but it does follow the 45, 45, 90 rule. So the question is, how far do I have to spin my spinner to create this situation? Well, it's 180 plus 45. That's 225. There's one of my answers. Now, do I need to convert this to radians? Well, it doesn't say to, so we're going to relax on that. But the other thing is, it can also happen over here because there's another negative square root of 2 and a 2 there. And this could be 45 reference angle also. But how far did I spin my spinner? Well, 360 minus 45, which would be 315. So you can see, you're going to have to build your triangles to get these answers correct. All right, example 10, completely different than example 9. So if you're looking for a pattern to use on every single problem, it's not going to work. Look, we got 2 sine squared x and we got sine x. What can I factor out of here? Sine of x. And I'd be left with 2 sine of x plus 1 equals 0. I think I did this exact same problem on the pre-lesson, but let's just investigate. So we got to look for where sine of x equals 0. That's this. But we also have to look at where does 2 sine of x plus 1 equals 0. This one should start becoming pretty obvious because we're starting to see this enough where at 0 degrees and 180, our opposite side disappears. And so therefore, there's 2 of our answers because we know that sine is opposite over hypotenuse. The only way we could have this equal 0 is if the numerator is 0. How about this one? Subtract 1, subtract 1. 2 sine of x equals -1. We're going to divide by 2. Sine of x equals -1/2. Again, in order for sine to be negative, that negative needs to be attached to the numerator. So we know my opposite side has to be minus. So that's -1. Well, this is a little different. And then I also know that it can be -1 over here. And if my hypotenuse is 2, I can clearly recognize this as a 30, 60, 90 because that is the relationship between the short side and the hypotenuse. So I know that's 30, and I know that's 30. This problem is asking you, how far do you have to spin your spinner to create this scenario or this scenario? So we'll go here first. It's 180 plus 30, which is 210. And then this way is basically 360 minus 30, which is 330. So this problem has 1, 2, 3, 4 answers to it. Next problem. Remember in my pre-lesson I said, get into the habit of setting it equal to 0. Now why didn't I do that up here? Well, it's not something I'm going to factor. See, I factored this, and I'm going to factor this. I can just look down the road. Here's what I mean. If I subtract sine from both sides, these are not like terms, so I cannot actually subtract them, so I'm going to go like this. I know these are weird looking, but you'll get used to it. And see, I want to factor this and this out. So I'm going to go sine of x, 2 cosine of x minus 1 equals 0. So this is testing your algebra skills as well as your pre-calc/trig. So I need to investigate, where does sine of x equal to 0? And not to just be lazy, but didn't we just do that one? So it's 0 or 180. And now let's investigate this. I'm going to go 2 cosine of x minus 1 equals 0. So I'm going to add 1, 2 cosine x equals 1, divide by 2, divide by 2. Cosine of x equals 1/2. That means my adjacent side is 1. That means my hypotenuse is 2. Remember, the only special triangle where one side is exactly half the other is a 30, 60, 90. You got to pick up on that little clue. And so I know I'm going to chew up some of this space, but I have to. So first of all, cosine is positive. That means a triangle over here, remember this is my adjacent side, or a triangle over here, this is my adjacent side, which is negative, just eliminated these two quadrants. So I need to look into here. If this is a 1, and this is a 2, and that's the square root of 3, this would be a 60. And see, cosine of 60 degrees would be adjacent over hypotenuse. So there's one of my answers, 60. But if I kind of just do a mirror image, this is my negative square root of 3, which I don't really care about, and that too, cosine, if this is 60 degrees, sorry if this is a mess, would also give me 1 over 2. So 60 degrees is one of them, but if I spin my spinner that far to create this triangle, I'd get 300 degrees. So for this problem, 0, 180, 60, and 300 would give me the correct answers. All right, we have a classic trinomial right here. See that? This is like 2x squared minus x minus 1. And if you let your brain just kind of think of it that way, you'll have a lot easier time factoring. So this is 2 cosine x, cosine x. Remember, there's a negative 1 in here. And if this is a negative 1, I know this has to be a 1 and this has to be a 1. But I have to make a decision because one of these is negative, one of them is positive. I'm going to make this one my negative because remember, if I go FOIL, this times this gives me this. And I go outside and I get negative 2 cosine. Inside I get positive cosine. And so that would give me my negative 1 cosine. That's just factoring and then FOIL to check if you factored it correctly. So this has to be plus. And now I have to investigate each scenario. So I got to go 2 cosine x plus 1 equals 0. And I got to set this equal to 0. Cosine x minus 1 equals 0. So I subtract 1, I get 2 cosine x equals negative 1. So I get cosine x equals negative 1/2. Now I can kind of piggyback this. Remember I got over here cosine equals positive 1/2? And I said we were stuck in the first and the fourth quadrant. Well, this one must mean then I'm stuck over here. So here's my -1, here's my 2, that'd be my square root of 3, which tells me, sorry about this, oh no, terrible eraser. That angle right there is 60 degrees. This is -1. But if I redraw it, I'm also going to say that this is -1, this is negative square root of 3, this is 2, which tells me that this little guy is also 60 degrees. But the question is, how far did I spin my spinner to get to that 60-degree reference angle? Well, this would have to be 120. And then how would I get to here? Well, that'd be 180 plus 60, which is 240. So I got 120, 240 for this right here. I still need to investigate this. Add 1 to both sides. Where does cosine of x equal 1? You got to use your noggin. That means the adjacent and the hypotenuse have to be equal, and there can't be any negatives. If I look at this right here, look at it. This is my adjacent side. This is my hypotenuse. At 0 degrees, cosine would equal 1, because this over this, because they're equal, would be 1. If I went over here, it couldn't work, because this is negative and this is positive. That's why 180 is not an answer, but 0 is. And there's our 3 answers, 0, 240, 120. Last problem. Once again, we have a trinomial, but I beg you guys, if you're going to have to factor, set those equal to 0. And now factor. So this is going to turn into 2 sine of x, and this is sine of x. Now this is a -1, so I know both of these have to be 1s. Now I have to make a good decision here. I want a +1 sine x when I'm done, so I'm going to attach this to the positive. So I got to make that a positive and this a negative. That's a big move, so you kind of have to be good with factoring your trinomials. That's why you took Algebra 2. So 2 sine of x minus 1 equals 0 is something I have to investigate. And then I have to investigate the other thing as well. I'm going to add 1. 2 sine of x equals 1. Divide by 2, divide by 2. I get sine of x equals a half. I might as well just finish this one. Sine of x equals -1. Well, where could sine equal a positive 1/2, where this is my opposite and this is my hypotenuse? It'd have to be here, where this is a 1 and this is a 30, or here, where this is a 30. You see, that's the only way you're going to get sine to be 1/2. If I went down here, that'd be -1, so that didn't work. If I go down here, that'd be -1. So then I'd be introducing negatives, and I can't. So that'd be 30 degrees for one of my answers. But then I would also flip it to here, which would be 150 degrees. And there we go. Now how about sine is equal to -1? Remember, sine is opposite over hypotenuse. So how could this equal a -1 question mark? Well, the opposite would have to be exactly the same size as the hypotenuse, but the opposite would have to be negative. Look at 0 degrees, the opposite side disappears, so that can't be it. Here, the good news is the opposite does equal the hypotenuse, but there's no negatives. Once again, the opposite side would disappear, so it didn't work here, it didn't work here. Looks like something good's going to happen here, so let's check it out. There's my opposite side, and it's negative, and there's my hypotenuse. See? And at 270, the opposite side would equal my hypotenuse, but the opposite side is negative. So there's my one answer for this situation. But then I've got these two also. And that's it, you guys. Have fun with that assignment. Go after it.